Hello guys, welcome back to Tronic Synergy. So today I'm going to explain a very important feature that I'm going to use in the brain circuit. So right here what we have is a single pulse generator, which I'm going to call interrupt of the circuit. So basically how this interrupt will be functioning once the power is on is going to give a single pulse or a single trigger, and then the stable state of the circuit will be, or the default state will be, off. So once the pulse is over, then the circuit goes off even if the power remains on. So that feature, we are going to use it in the you can see right there we have the priority selector circuit, which is here. So if you can remember, when I was doing this circuit, if a special state or if a special condition was met, I had to press this button in order for the circuit to decide what to do, or a special task to be taken. So in a normal system, someone cannot just go there, be pressing every single time. We want the circuit to do that by its own. So this is what we are going to replace with this feature, which you're going to call interrupt. So that single short pulse is what we are going to need for the circuit to operate efficiently. So basically how it operates, right here the capacitor starts at low voltage, 0 volts, once the power is on. So right here at this junction it's going to be low. It's going to be low. So because the input of the Schmidt trigger is low, meaning that the output is going to be high, and that high output is our trigger. That high is not going to stay for long because the capacitor is charging slowly. Once the capacitor charges and its threshold reaches more than the required one, then it's going to output. So this point is going to be high. Once this point is going to be high, then the rest of the circuit is going to be low, because the trigger is an inverter. So once it's high, it's going to be low at the output. So that low is going to remain like that because the capacitor is fully charged and cannot be discharged. There's no other mechanism to discharge the capacitor. So the default state of the circuit is going to be off. That's how the circuit is going to be for the rest of the period. So that single short pulse is what we need in our circuit, because we don't want it to give different or give a false trigger. That's not what we want. So you can still use other trigger ICs, but this is the one that's very efficient because it also filters false triggers, which can come in from very many ways in big circuit like that. So this is the circuit. So if I just turn this on, if I just place this jumper at this point, then the LED will turn on quickly and turn off quickly also. So if I just, you can see it turns on quickly, then turns off quickly. If I can do that again, just, you can see turns on quickly and turns off also quickly. And even if the power is on, the default state of the circuit is just to be off. So that's basically what we need in our circuit: a single pulse, and then goes off for the rest period of time until the circuit is turned on again. So that's basically what we need in our priority selector. And yeah, so that's how it operates, and that's what I wanted you to see today. That's a very good feature which we are going to use. Also, this feature is what is used in our modern day CPU. The feature called interrupt. So once the CPU, once you turn it on your PC or your computer or whatever, the program runs continuously, nothing stops. So if something comes in and needs the attention of the CPU, then an interrupt signal is going to be sent to the CPU. Tell it, come, hey, I have a request and I want you to do this fast. So the CPU first stops its activity, does what you want, and then goes back to the initial program to continue its normal operation. So that's basically how an interrupt signal operates or functions in our modern day CPU, and that's how it's going to function also in my circuit. So because it's continued doing its normal work, if a special state or if a special condition has been met, then an interrupt signal is going to be taken to the CPU for it to decide what to do about that special case. So thank you very much guys for watching. Please subscribe to Tronics Energy, and I hope to see you next time. Goodbye.